Interpretation of the main functions of hose pump intelligent controller. Hose pump is a kind of fluid transportation equipment. Its working principle is based on the alternate compression of elastic hose to realize the transportation of medium. Specifically, the hose pump is usually driven by a motor, which drives the runner to rotate through a gearbox, two pressure rollers or shoes with rotating wheels distributed at 180 degrees, continuously squeeze along the surface of the hose. Cooperation with the pump casing can make the hose to be crushed, thereby creates a vacuum suction, drawing fluid into the hose. After the fluid enters, it will be flattened again by the subsequent pressure roller or shoes, and flow to the outlet in the hose, and finally be squeezed out of the pump. Since only the hose is in contact with the medium, the risk of the pump contaminating the fluid or the fluid contaminating the pump is avoided. With this advantage and its easy-to-maintain structural features, it has successfully met the challenges of harsh working conditions and special media time and time again. Its performance is better than other pump types under the same working conditions, and gradually accepted by users. Through sufficient market research and application feedback from industry users, Hankun has discovered the following pain points. Ordinary hose pumps cannot monitor pressure, flow, without remote control and monitoring, and cannot alarm or shut down when error. In response to these problems, Hankun analyzed the product characteristics in depth, developed and launched an intelligent transformation solution for industrial hose pumps, the Hose Pump Intelligent Controller, which specifically solves the problems that are prone to occur during the application process of hose pumps. Improve the overall operating life and stability of the pump. The Hose Pump Intelligent Controller has the following functions. 1. Pressure monitoring. When the hose pump is working normally, there will be a certain pressure at the outlet. Different working conditions have different pressure requirements. When the outlet is blocked or the valve is not opened in time, it will build pressure, cause the hose to rupture, then lead to leakage of corrosive media and safety accidents. Thus, the operation and maintenance costs will increase. In response to this situation, two pressure sensors are installed on the hose pump. The first pressure sensor is installed on the pump casing to monitor whether the hose is ruptured. When the hose ruptures, the pressure in the pump casing will rise. At this time, the controller can automatically cut off the motor power and stop the pump in time to avoid more serious problems. It can also provide an alarm signal for the customer to handle. The second pressure sensor is installed on the insert of the hose outlet. When the outlet pressure exceeds the critical pressure value set by the intelligent controller, the controller will automatically cut off the motor power or provide an alarm signal for the customer to handle. Avoid error damage to the hose caused by pressure at the outlet. 2. Flow monitoring. Traditional hose pumps cannot display flow directly. If users want to see real-time and accumulated flow, they need to install an additional flow meter, which increases the cost. This solution integrates a proximity sensor on the pump casing and calculates the pump speed by monitoring the time difference between two approaches of the hose pump runner, thereby accurately calculating the flow rate. The flow information is displayed on the screen of the controller. The controller can directly control the motor or indirectly control the flow through the frequency converter to meet the different needs of users. When the controller controls the converter, the frequency of the converter can be adjusted on the controller screen to control the motor speed to adjust the flow rate. 3. Remote control and monitoring. The working environment of the hose pump is relatively harsh, and on-site adjustment is inconvenient. The controller can solve this pain point very well. There are two ways of controller. The first is remote signal. The controller can send and receive 4 to 20 mA current signals externally through the remote signal line, which is used to feed back the current flow and control the motor speed to adjust the flow. The second type of IoT signal. By integrating the IoT module, users can obtain pump operation data in real time, control the start and stop of the hose pump, and adjust the operating speed if it has a frequency conversion function. The cloud monitoring value-added services provided by Hankun are even more refreshing to users, making operation and maintenance management easy to handle. 4. Error alarm. The real-time operation of the hose pump is monitored through sensors. When it occurs error pressure, temperature, flow, motor etc., there are 3 alarm methods to remind the user to deal with. The first is on-site. The controller will drive the buzzer to sound an alarm. The second is a remote signal, which is connected to the user's DCS system through a remote signal line to feed back error information. The third is an IoT signal, which is sending a text message to the user's mobile phone through the network. Hankun's intelligent hose pump solution is like adding a pair of smart wings to the hose pump, making the hose pump that has already performed well in industry applications even more powerful, and solving more practical problems for customers.
Hankun quality driving the future.